Alright, section 6.5 talks about derivatives of inverse trig functions. And if I have y equal the sine inverse of x and I want to find the derivative, of course we don't know what the derivative of inverse sine is, so what we do, we say, well, that must have been the sine of y equal x. That's a trig function right there. That is the opposite over the hypotenuse, if you recall. And now if I take a derivative, differentiate both sides, I'll get the cosine of y times dy dx equals a 1. So basically dy dx equals 1 divided by the cosine of y. And I'll get dy dx to be 1 over. And if I take this and create the triangle, there's the angle y, the opposite is x, the hypotenuse is 1. To find this side, a, I would say 1 squared equal x squared plus a squared, so a squared equals 1 minus x squared, and a would equal the square root of 1 minus x squared. So it is plus or minus, but because of the limitation on inverse, we know that it's positive. And if I want the cosine of y, so this side right here is the square root of 1 minus x squared. Cosine is the adjacent over the hypotenuse. And there it is. dy dx would be 1 over the square root of 1 minus x squared. And that's pretty much the first. So, 3 functions only. Derivative of inverse sine is 1 over the square root of 1 minus x squared. Luckily, derivative of inverse cosine is exactly the same with a minus. And derivative of inverse tangent, something that is going to come up a lot more than you like. That's 1 over 1 plus the argument squared. So, I have a few examples I want to look at. I would start with example 1. Differentiate the following functions. I have a combination of those. So here, dy dx, by the way, this book calls it arc cosine. Other books call it inverse cosine. It's the same thing, just different notation. Same function. Derivative of inverse cosine is 1 over the square root of 1 minus the argument squared. The argument in this case is 2x. Don't forget the negative for cosine inverse, times the derivative of the argument by the chain rule, and there it is. That would be my answer. So the idea is fairly simple. It's gonna require you to use the product rule, the quotient rule, the chain rule, the power rule, on and off. Same thing here. If I want to find the derivative, let's say y prime is 1 over twice the radical of whatever that is, times the derivative of the inside by the chain rule, which is 1 over 1 plus the argument squared, times the derivative of the argument, which is a 3. And that answer right there is fine. And here, if I want to find dy dx, the same deal. That's 1 over the square root of 1 minus the argument squared, times the derivative of a radical, which is 1 over twice the radical of x. The derivative of inverse tangent, 1 over 1 plus the argument squared, times the derivative of 5x minus 2, which is 5. So this section should run smoothly. It should reinforce your knowledge of the derivative, properties of product rule, quotient rule. Again, here y prime is, you bring the power down, subtract 1 from the power. Times the derivative of arc sine, which is 1 over the square root of 1 minus x squared. Here I need the quotient rule. Y prime is derivative of the top times the bottom. or denominator, minus the top times derivative of arc cosine, the same as sine with a minus, all over the bottom squared. On a test, I'm fine with this answer. For the homework, you really want to clean it up. The LCD is the radical, so multiply by 1 minus x squared times 5 x to the 4th inverse cosine of x plus x to the 5th all over the square root of 1 minus x squared, the inverse cosine of x squared. Do not mix an inverse cosine. That's why I like this notation more than this. Do not mix the inverse sine or inverse cosine with a function to raise to the power of -1. That is only used because of the notation of our inverse, nothing more. And if I look at the last example I have, y prime would be derivative of the top times the denominator minus the top times the denominator all over the denominator squared. Again, that's a fine answer. There's nothing wrong with that answer. Most likely in the back of the book, they would go ahead and combine them into one. Complex fractions came up a lot in your previous course. LCD is 1 plus x squared, so that's x plus x times 1 plus x squared times arc tangent. I said plus, I meant minus, my mistake. All over 1 plus x squared times x. You could factor an x and clear it up a bit more. And you could cancel those x's. And there it is. That would be your final answer. And that's pretty much it for this section.